So these are the two free body diagrams for this system. I'm going to sit here for 5 seconds for you to pause the video and copy the two free body diagrams down. Okay, so at this point, when we have these two free body diagrams, one is the right free body diagram is simply more detailed than the left. However, the left has information that the right does not have. So for part A, we're going to, let's draw a triangle that will help us. If this is B, if this is point P, this is point B, and this is point A, we can say that this is going to be R minus H. This distance here would simply be B, and then this would be R. So we can say that this is also angle theta. So we can say that for part A, we can say that n sine of theta is going to be equal to mg, and we know that n cosine of theta is going to be equal to f. So at this point, we can say that mg divided by f, let's clean this up, mg divided by f is going to be equal to n sine of theta divided by n cosine of theta. So we're essentially just dividing both of these equations, and we find that this is going to be equal to tangent of theta. So we can say that f is going to be equal to mg over the tangent of theta. At this point, we can say that theta is going to be equal to arc sine of r minus h divided by r, and we can say that f is going to be equal to mg divided by tangent arc sine of r minus h divided by r, close parentheses once more, and we can say that from the triangle, once again, tangent of theta equals r minus h over b, and so we can say that due to Pythagorean theorem, r minus h squared plus b squared equals r squared, and so b is going to be equal to r squared minus r minus h squared to the 1/2 power. And so we can say that the force now, after substituting all of this in, is going to be equal to mg times r squared minus r minus h squared to the 1/2 power, and then divided by r minus h. This is simply going to be equal to mg times 2rh minus h squared to the 1/2 power divided by r minus h. This is going to be for the center of the wheel. So this would be the magnitude of the force given that you're applying it at the center of the wheel. Now for part B, they want us the magnitude of the force at the top of the wheel. So here the torque is going to be equal to mg times r squared minus r minus h squared to the 1/2 power. Again, this will equal f prime of 2r minus h. And so we can say that f prime is going to be equal to mg times r squared minus r minus h squared to the 1/2 power once again, and this will be divided by 2r minus h, and again this is equaling mg times 2rh minus h squared to the 1/2 power divided by 2r over h, and this is going to be for the top of the wheel. And as you can see, force prime is less than f because force prime has a denominator. 2r minus h is going to be greater than, of course, r minus h. And if the denominator is greater, that means that the result is going to be less than the magnitude of the force at the top of the wheel will be less than the magnitude of the force at the center of the wheel. So this means that if F prime is less than F, this means that there is less force required in the second case, or case B. So this would be the answer for part C. That is the end of the solution. Thank you for watching.